Okay, so looking into the second part of polynomial curve fitting. Okay, now the first problem is we dealt with an odd number of points to work with, and now let's say we have an even number of points, and we have as a case here, say we're looking at determining the polynomial that runs through the following points, where we have 2, -9, 3, -35, 4, -83, and 5, -159. So again, the value n is the number of points, okay, which is going to be 4. And the degree of the polynomial, again, is going to be 1 less than the total number of points. Okay, so we have n minus 1 is equal to 3. And we have, once again, for the general polynomial layout, okay, so we have p of x is equal to a naught plus a of 1 times x plus a of 2 times x squared plus a of 3 times x to the third. And just looking at setting up our system. Okay, so we got, again, so we have the these 4 points have been set up with respect to what we have with the first, second, third, and fourth set of x and y values. And again, just going back to setting up our equations. Okay, so in line with working with the first x and y values, okay, so we have the general case a naught plus a of 1 x of 1 plus a of 2 x of 1 squared plus a of 3 x of 1 cubed is equal to y of 1. And then we had the same setup for the x and y terms with the same subscripted values. Okay, so we're going from subscript 1 in x and y to subscripted 2 for x and y to 3 as well as 4. And looking at substituting, okay, the values. Okay, so we have for x of 1 at 2 and y of 1 at -9. So we got this general setup, a naught plus a of 1 times 2 plus a of 2 times 2 squared plus a of 3 times the cube of 2 is equal to -9. And just following through the same mode of substitution for x of 2, y of 2. So again, I have a naught plus a of 1 times 3, a of 2 times the square of 3 plus a of 3 times the cube of 3 is equal to -35. And we have with y of 3 at -83 and x of 3 at 4. So again, we run 4 through the same treatment as we did with 2 and 3. And 5 we're going to do likewise, where 5 is going to be the x of 4 and -159 is going to be the y of 4. And just looking at what we have and following through. So we have this system of equations. Okay, so once we translate in terms of a matrix, okay, we'll have 4 rows, 5 columns, and just taking what we have in terms of the lineup. Okay, so what we have in a naught, we have the coefficients at 1 throughout. Our a of 1 terms, we have the coefficients 2, 3, 4, 5. For a of 2, we have 4, 9, 16, 25. For what we have for a of 3, we have 8, 27, 64, 125. And again, we had the y values on the right hand side. And again, just to express in terms of reduced echelon form or row echelon form. Okay, so if I make the first column where we have 1 at the top and zeros to follow through, and I can proceed by taking r2 minus r of 1 for the second row, and then for the third row I have r3 minus r of 1, r4 minus r of 1, and throughout you're going to have 1 minus 1 to land at zeros for the second, third, and fourth rows, and just again subtracting in addition to 1 if you subtract 2, 4, 8, and 9 from the corresponding parts. Okay, this is what we have for the second matrix. Second row we have 0, 1, 5, 19, -26. Third row we have 0, 2, 12, 56, -74. Last row we have 0, 3, 21, 1, 17, and -150. Okay, so for the row echelon form, okay, the top row we have 1 in the upper left hand corner. Next row I want 0, 1. And the next one I want 0, 0, 1. So to make this 2 into a 0, okay, I'm going to have to take away 2. Okay, so you have r3 minus 2 r of 2. And also for the ultimate goal, okay, for the last row, I want the pattern to be 0, 0, 0, 1. Okay, and so I can make this 3 into a 0 if I take 3 away. And so we have r of 4 minus 3r of 2. So looking at what we have, again, I've done the work in the row echelon form for the first and second rows, modifying the third row. Okay, so I'm going to have in this layout, okay, so we have subtracting from the second row, okay, double 0 as well as 1, 5, 19, and negative 26, from 0, 2, 12, 56, and negative 74. Okay, so I have 2 minus 2 is 0, and what's going to be 12 minus 10 is going to be 2. 56 minus 2 times 9 is going to be at 18, and negative 74, and what's going to be plus 52 is going to be a negative 22. And for what we have for the last row at this stage, okay, so you got 3 minus 3, 21 minus 15, 117 minus 57, and what is going to be negative 150 plus 78. So I got the last row at this stage consisting of 0, 0, 6, 60, and negative 72. And transporting this over, okay, so I'm getting closer to the row echelon form. So again, I had the triangular pattern 1, 0, 1. Now I want 0, 0, 1, and so I can change that 2 into a 1 upon taking half of the third row, leaving everything else unchanged at this stage. So we got same first, second, and last rows. Third row is changed over to 0, 0, 1, 9, and negative 11. So again, I have in this formation got the triangular pattern 1, 0, 1, 0, 0, 1, and I want 0, 0, 0, 1. And I want this 6 in the bottom row to be transformed to 0. And so what I'm going to need to do is to take away 6 from this corresponding portion, and leaving the first two columns values of 0 in the last row at 0. I'm going to interact the last two rows. We're going to have r of 4 minus 6 times r of 3. So again, I have 0 minus 0 is 0, 0 minus 0 is 0, 6 minus 6 is 0. Now we have 60 minus 54, which will be 6, and negative 72 plus 66 is going to be negative 6. And guess what? I'm ever so close to the row echelon form. So changing the 6 into 1, I can take 1/6 of the last row. And so in the transformation, I have 0, 0, 0, 1, and negative 1. And this is going to be the row echelon form. And putting in terms of what we have with the coefficients, again, a naught, I got negative 9, minus 2a of 1, minus 4a of 2, minus 8a of 3. And for a of 1, again, I have negative 26, minus 5a of 2, minus 19a of 3. And for a of 2, this will be negative 11 minus 9a of 3. And for the last row, we'll have a of 3 is equal to negative 1. And so just setting up what we have here, so I have a of 3 is equal to negative 1, and plugging in negative 1 for a of 3 for a of 2. A of 2 comes out to negative 2, and then plugging in negative 2 for a of 2 and negative 1 for a of 3. Utilizing the setup equation for a of 1, okay, so that is going to come out to a positive 3. And for a naught, now that we had the values of a of 1, a of 2, and a of 3 already established, we have for a naught, okay, as we fill in 3 for a of 1, negative 2 for a of 2, and negative 1 for a of 3, and substituting accordingly, the value of a naught will come out to 1. And again, with the values of a naught all the way out to a of 3 specified. And again, this is our general setup and filling in. So we had the polynomial p of x is going to be 1 plus 3x minus 2x squared minus x cubed. And again, just for the table, and I include the corresponding graph. Okay, so with this polynomial, so if x is 2, I got negative 9. 3 for x translates to negative 35 for y. X at 4 comes out to negative 83, and x at 5 comes out to negative 159. And so you have just a portion of the graph of this particular polynomial curve. All right, Now where we have very high values in x, okay, say if I have, in this particular case, for this set, I left the same y values and I increased the x values by 2000, where I have 2002 negative 9, 2003 negative 35, 2004 negative 83, and 2005 negative 159. And again, I have 4 points, and we have n minus 1 equal to 3. And just for the general polynomial setup, again, we have p of x is equal to a naught plus a of 1x plus a of 2x squared, and we have plus a of 3 x cubed. And now we have an even number of points, and ideally, okay, if I had like 5 points or 3 points, I would want to set z equal to x minus, okay, the middle x coordinate. Like if I had like 2002, 3, 4, 5, and 6, ideally I would have like z equal to x minus 2004. And I don't care to work with fractions, and so we have with this even number of points, I'm just going to let x minus 2002, the first x coordinate, be the setup we have for z. So z is equal to x minus 2002. And if I change what I have in x and y over to terms that we have in z and y, so you have like 2002 minus itself is 0. From 2003 got 1, 2004 got 2, 2005 got 3. Same y values. And so we're going to have utilizing these first coordinates. Okay, this will be for what we have in z, while z is equal to x minus 2002. So I'm using an auxiliary route going from p of x to p of z. And again, I have a naught plus a of 1z plus a of 2z squared plus a of 3z cubed. And so starting out with, instead of x of 1, y of 1, all the way down to x of 4, y of 4, I have the subscripted x's at the moment replaced with what I have in z. So we have this system of equations. And filling in, so again, the first z we have at 0, so we have a naught equal to negative 9, and the second z I have at 1. Okay, so we have a naught plus a of 1 plus a of 2 plus a of 3 is equal to negative 35, and with the third z at 2, substituting accordingly, so you got 2 squared, 2 cubed, and with z of 4 at 3, so I got 3 squared, 3 cubed, okay, times a of 1, a of 2, and a of 3 respectively. And to the right, I have those y values, negative 9, negative 35, negative 83, and negative 159. So I have with this system, I can set up in terms of a matrix. So again, I have 1 a naught, and notice we have no a of 1, a of 2, or a of 3 expression. So I got negative 9. And then I have second equation I have represented by this row, third equation 1, 2, 4, 8, negative 83, and the last row corresponding to the last equation in the setup between z and y, so you have 1, 3, 9, 27, negative 159. And again, for the first column, I want the bottom 3 ones, okay, to be transformed to 0. So I can take the elements from the first row away from the second row, and then the third, and then the fourth. And so just with the adjustments, okay, so we have for the second row, I got 0, 1, 1, 1, negative 26. And then taking, again, 1, 0, 0, negative 9 away from 1, 2, 4, 8, negative 83. I have 0, 2, 4, 8, negative 74. And again, taking the same elements away from the last row elements, I got 0, 3, 9, 27, negative 150. And we're getting closer to the row echelon form. So again, I want in the triangular formation like 1, 0, 1, and then 0, 0, 1. And right now I want to make the 2 and the 3 from the third and last rows to be 0. So I'm going to take r of 3 minus 2 times r of 2 for the next display in the third row. And for the last row, I'm going to take, since I need to change this 3 to a 0, I'm going to take away 3 by taking away the elements from the last row, or taking away from the last row elements 3 times what I have from the second row. And so in the procedure, now we got 0, 0, 2, 6, negative 22 for the change up for the third row. Last row we'll have 0, 0, 6, 24, negative 72 for the last. And again, we're getting closer. So we got 1, 0, 1. Now we got 0, 0, 2, and I want that 2 to be a 1. So I'm going to take half of the third row elements, and leaving everything else unchanged at the moment. I'm going to have 0, 0, 1, 3, negative 11. And then now, so again, I want 1, 0, 1, 0, 0, 1, and I want the last row to consist of at the front 0, 0, 0, and 1. And so I have to take care of the 6 itself. And so looking at what we have now, okay, so to keep the zeros from the last row intact and changing the 6 to 0, I'll be taking away 6 times the third row elements from the last. And so we got 0 minus 0 is 0. Still 0 minus 0 is 0. Now we got 6 minus 6 is 0. 24 minus what's going to be 18 is going to be 6. And negative 72 and what's going to be plus 66 becomes negative 6. And then taking 1/6 of the last row, and we finally have arrived at the row echelon form where we have 0, 0, 0, 1 and negative 1 for the last row. And so with the row echelon form, again we have A naught is equal to negative 9, and A of 1 you have negative 26 minus A of 2 minus A of 3, and then you have A of 2 is going to be negative 11 minus 3A of 3, and we already have situated that A of 3 is equal to negative 1. So looking at back substituting with A of 3 at negative 1, we have A of 2 is equal to negative 11 minus 3 times negative 1. So this will change over to addition, where we have 3 added to negative 11. So we have A of 2 is equal to negative 8. And for A of 1, okay, so we have negative 26 minus A of 2, which is going to be negative 26 minus negative 8. And subtracting negative 1 is going to change over to addition of 1. And so A of 1 is equal to negative 17. And again, we already have established that A naught is equal to negative 9. And again, we had momentarily put the polynomial in terms of the variable z, but we're also going to put it back in terms of the variable x. So right now, with our values going from A naught to A of 3, and filling in, we got for P of z, we got negative 9 minus 17z minus 8z squared minus z cubed. And again, since we had established that z is equal to x minus 2002, and we have upon replacing z with the binomial we have in x, we had that p of x is equal to negative 9 minus 17 times the quantity of x minus 2002 minus 8 times the square of the quantity of x minus 2002. And finally, we have minus the cube of the quantity of x minus 2002. And if you were to test out what we have for p of x, and we have with the respective x amounts of 2002, 2003, as well as 2004 and 2005, we're back to those same y values from the beginning.